Today's session is going to be short. Basically, we are continuing with our introductory online lecture last couple of weeks before Raya, and then we're gonna continue on our new topic, which is the orbit determination, preliminary orbit determination. So orbit determination. Now, why I say this is preliminary, because one major reason is because we are still using our assumption of two-body motion. Okay, we assume everything follows the two-body motion, and that's why all our math, physics is all they are all based on this assumption. Okay, later on, probably towards the end of the semester, we are going to discover about the three-body motion, where when you have a third body, gravitating body in a system, how would you, we will look at the type of orbit, the Lagrangian points, and we will look at into some examples, existing examples of Lagrangian points and three-body mechanics. So that will be at towards the end of the semester, but all we are doing right now is what we have learned so far, two-body motion. Okay, so we are still at this the first two topics here, Julian date and local sidereal time, or local sidereal time. So from our discussion last time, these two are basically a measurement of time. So for example, if you have, let's say this is a timeline, okay, and let's say this is back when it was January 1st 4713, and let's say this is now the present. Okay, let's say you have some astronomy event, this here, all right, and let's say you want to find the time difference between the time now here and the time when that astronomical event happens. Let's say it's an observation of a comet or whatever astronomical event. So you want to figure out the time between these two events, present and whatever events before. So let's say you want to count the time that. So here we don't use days. We don't say the event occurred like 5 years, 4 months, 2 days ago. So that is pretty hard to make it to make the time convention really to formalize it, to make it general for everyone. So what we use is Julian Day. So as you know, we have a system called Julian Day, which will give this delta t, the time difference here, in terms of Julian Day, which is there's an example here. So yeah, so to calculate that, then to find delta t, the time between these two events, present and the previous event, we can just calculate Julian Day in this event, and we can calculate the Julian Day in this event. Okay, and then, well, delta t will be just jd2 minus jd1. Okay, and how to calculate jd, Julian date, we have gone through the formulas and everything, so I hope you can look at these slides here. I've already given you, well, it's not really that terrible, except maybe there are some new things that probably this is the first time you see it, most time you've seen it, like this one here, int, the function int, which is simply is just take the integer of a number. Okay, so that's Julian date, and with these two slides, you already have the knowledge on how to find Julian date if you're given certain time, like calendar time, like 2004 May 5th at 2 o'clock local time. What is the Julian date? So you can find it using this formula. Okay. So is everyone still here, or am I talking alone here? Because I need to check from time to time.
I'm here.
Okay, nice. I have to check from time to time because I noticed that my internet connection is not very good this past few days. Okay. All right. Okay. So that's Julian date. Now, okay. Last time I didn't have the chance to actually properly explain this sidereal time and solar time. But let's do this. Let's say, oh, by the way, there's a mistake here. This one is, I think this is 4 seconds. Okay, not 9.5. I don't know where I got that number. Okay, so let me explain to you between these two type of day. I would say one is what we call solar day, okay, and the other one, let's call that sidereal day. Okay, so it's like this. Let's discuss about sidereal day first, okay, because I think that's that's easier to understand than solar day actually. Okay, let's imagine that you have, let's imagine this is Earth. Okay, imagine this is Earth. Oh, terrible. Let me try and make it proper circle. Ink to shape. Go. Oh, it's not gonna happen. There you go. Let's do that. Okay, let's say this is Earth. Yeah. Let's say we are looking at Earth from top, from the north. So we're looking down. This is the north, that point. Okay. And then let's say you are sitting there. Okay. Okay. Obviously, this is not real size. So the Earth is rotating in one way. Let's say at this time, if you look above you, you will you find that you're looking at a star, a distant star. Okay, the distant star, because it's so far away from us, it looks like it is fixed in our sky. Okay, so let's say at this time you see the star right above your head. Okay, and as you know, because Earth is rotating as well, so let's say you also rotate. Okay, and then when you rotate, by the time you got back here, you see the star again on top of your head. Okay, so the star again, it means right now you see on top of your head there's a star. So you wait a few hours. After that, sometime tomorrow, you will see the star on top of it again. So can someone tell me actually what is the time here? How many hours does it take to actually see the stars on top of your head again? The answer is actually not 24 hours, but it's 23 hours, 56 minutes, about 4 seconds. Okay, there you go. It's almost 24 hours. Okay, now this is when we say, usually in astronomical in astronomy or in space mechanics, yeah, when we say a day, a sidereal day, this is the actual number we use, yeah, 23 hours 56 minutes 4 seconds. Okay, now what's the difference with solar day? Solar day is actually 24 hours. Okay, so let me show you what's happening in solar day. For example, let's look at the same situation just now. Okay, let me find a perfect color for the sun. Where's yellow? Is this yellow? Okay, let's say this is the sun. Okay, let's say at this time you see the sun right on top of your head. This is a midday, like dead midday. Sun is on top of your head. Okay, so you wait a few hours, you know, Earth is spinning, and then tomorrow you record the time when you see the sun is on top of your head again. So this time is actually when you see the sun again. Sorry, let's say the time when you see this is the sun has actually moved here a bit, just slightly away. So you actually have to wait for a few more minutes to actually get the sun on top of your head. And this is actually why it is 24 hours, not 23 hour 56 minutes 4 seconds. You have to wait a bit more, a few more minutes to actually get the sun on top of your head. Now, why is this so? The reason is because when the Earth is also moving around the sun. Okay, so let's say this is Earth. Okay, so Earth is also moving around the sun. So just now what we do is we wait for the Earth to turn to look at the same stars away. But right now we are not referring to a star, we are referring to the sun. But when the sun is on top of your head again, Earth has actually moved a bit here, right? Because the Earth is also moving around the sun. So this small tiny difference here is what makes this couple minutes difference here, 3 minutes 56 seconds. Okay, so this small difference here, if you add up to this number here, you'll get 24 hours. So solar day is the calculation of when you see on top of your head sun, and then you wait tomorrow, you see that sun again right on top of your head. Okay, so that's actually 24 hours. But sidereal day is when you are looking at a star on top of your head, a distant star. Okay, when you see a star on top of your head and then you wait tomorrow until tomorrow, you see the star on top of your head again, it's actually 3 hours 56 minutes 4 seconds. The reason is because here takes longer is because actually your Earth has moved a bit in the orbit, so that the sun, it takes a while. There's a short while to get the sun on top of your head again. So that's why one solar day is for 24 hours and one sidereal day, which means a day on Earth according to a distant star is 23 hours 56 minutes 4 seconds. Okay, so that is the difference between what is solar day and sidereal day. Now, let's say how do we calculate sidereal day, for example? Like let's say you are given, let's say you want to find the local sidereal day. Let's say you're staying in Kuala Lumpur, Malaysia. What is the time now? 2:21. 2:21 p.m. Okay, the date today is 2nd of June 2020. Alright, so what you see here, like I said, this is our convention of, you know, how do we calculate time, right? How we indicate time. We use 2:21 p.m. We have our own, you know, date system, Julian calendar, not Julian day. Okay, so my next question is, can you find the Julian day at this moment? What is it? Or more importantly, what is the local sidereal time? At this place, at this time and date. What is the local sidereal time? And local sidereal time, the symbol I'm going to use is theta, but I'm going to make it a bit different from the theta that we've got before, because you might confuse it with true anomaly. So I'm using this weird theta. Let me see if I can write that. Show you this data here. The math. Let's fix it. Let's see, it's done. Actually, it's not this one. This is the true anomaly theta. It's actually it's actually that. Okay, so I'm going to use this symbol here, theta. Local, so this is local sidereal time. Oops, local sidereal time. Okay, just so that we're not confusing it with true anomaly. So I'm gonna do that. So let's say you're given a local place, whatever it is. Let's say Kuala Lumpur, Malaysia, and you're given the time and you're given the date. Find the local sidereal time. Okay, so how do we actually find this? So it's a bit complicated, because you can't find local sidereal time by just looking at the clock. Basically, you need to look at the clock, and you need to look at the your position on Earth, okay, where you are. So local sidereal time is this one here. Yeah, theta here. Oops, it's too fat. Okay, let's try that. I think this is, yep, that's okay, I guess. So this is local sidereal time. So how do you calculate your local sidereal time? So if you can see from I think a page from the notes, let's say you are here. So let's say Kuala Lumpur is here. Okay, so to calculate local sidereal time theta, you need to actually figure out you need to know your position on the globe. Okay, so Greenwich at 0 hour university time is here. At that time, maybe somewhere here, and then you need to actually know your east longitude to figure out the your local sidereal time. Okay, of Kuala Lumpur. Okay, so to find local sidereal time, like I said, it's a bit more complex than just by looking at the clock. So I've prepared here some algorithm again. How to find local sidereal time. Okay, so let's say you're given a date and time and the place, local time, and then the east longitude of that location. Okay, so I think we are at the east of Greenwich. So, and I think ours is about 130 something, if I'm not mistaken. So if you are given the date and time and east longitude of our site, our place, Kuala Lumpur or Tokyo or Beijing, Buenos Aires, whatever, can you find the local sidereal time? Yes, but you need 5 steps to do it. Okay, so all the formulas have been given here. First, you need to calculate J naught, the Julian day at 0 hour universal time. You need this second formula here. You need this approximation here to calculate theta Greenwich at 0 hour universal time, and then you need to calculate actually the Greenwich sidereal time. Okay, and then you can find this. Now if you're using the textbook here, an explanation for this, you can find it in, I think, page 200, chapter 5. Yeah, chapter 5, you look at the chapter 5 preliminary orbit determination. I think page 200 something, yeah, 250, 251, and then there's a discussion on Julian day and sidereal time. You can look into that. But basically what I want you to do, because I think the best way to learn and be familiar with this Julian day and local sidereal time is to do the calculation yourself. Okay, reading the formulas is a bit boring and it's a bit overwhelming as well. So what I want you to do actually is to just to understand more about this, is to do an exercise. So let me show you something here. So here what I've done is, if you can see this, what I've done is I've created a simple calculator on finding Julian day. Okay, and actually, so you can see this here. No, I can't scroll it up. How do I do this? Yep, let's do this. Yeah. So basically, what this spreadsheet will do is it will cut. If I give it the date, local time, and the east longitude of the site, you can calculate local sidereal time. But I haven't made it that far. What I've done is a simple calculator to calculate Julian day. Oh, sorry, not Julian day. This is Julian day. Julian day at 0 hour here, and then Julian day at that time. So let's say today. So today is 2020. Let's choose 2020. Month is June, 2nd of June. Time is, let's see, 2:30. Okay, and 0 second example. Okay, so at this date, the Julian day is given here. So I've made that calculator. Okay, so this part is done. So just to show you how simple it is to actually calculate Julian day, although the formula might be a bit, it looks complicated, but it's actually very easy. I've done that for you. Okay, but what I want you to do though is to look at the algorithm for local sidereal time. Okay, again, what we look at this here, algorithm here, calculate J naught, calculate T naught, and everything here until you get the local sidereal time here. Okay, so how do we do that? So obviously you need the date and the time, and you need to know where the site is. Okay, so what I've done here, I've let's say our site is, let me see if I've included, let's say your site is at Copenhagen, Denmark. Okay, so the east longitude I've approximated from the data that I know is about 12.567 degree. Okay, And let's pick a nicer numbers. Let's say, okay, Auckland, New Zealand. All right. So, is it true Auckland, New Zealand longitude? Okay, longitude on the globe. Yeah. Oh yeah. So the longitude is about of Auckland, New Zealand. This is the latitude. Okay. The position on the globe, and the longitude is 174.76. Is it almost the same as my calculation? A bit off by a few degrees there, but just to show you latitude. So let me see if I can find something more interesting. So let's look at this, I guess. World map. Okay, so Auckland is, where is Auckland? This is Wellington. Okay. Wait a second. Auckland is in New Zealand, yeah? Oh yeah, here you go. Auckland here. That's pretty small. Okay, Auckland is there. So it's on the globe. It's about at about 175 degree east. Okay, so that's the east longitude. Talk about Auckland. So that's why in my calculator here, if I choose city to be New Zealand, Auckland, New Zealand, it'll give straight away the east longitude of that city. Let's pick another city. Of course, we're gonna play Malaysia. Malaysia, Kuala Lumpur. The east longitude of Kuala Lumpur is 101.7. Let's see. Is it so? Kuala Lumpur. All right, it's 101.68. I think it's, yeah, it's okay, I guess. So let's see, the position on the globe is there. Ooh, just yeah, I guess maybe I'll look at this one here. World map. 101.7, yeah, east. Okay. What kind of website is this? This is useless. Let me see if this website can give us any indication. Okay, but not really numbers though. Okay, so oh man, what is this? I can't find a good website just to show the longitude of a city. I guess this is the best I can show you here. So so that is 105 degree east. Okay, and Kuala Lumpur is right there, so it's about 101 east. So that's the east longitude of the city. So I have a few cities here. If you want to add more, like maybe Taiping, Perak, or I don't know, Kuching, Sarawak, you can add more, but you need to actually know the east longitude. So there's that. I've done the calculator for Julian Day. It's easy, but I think I need you to continue the job here, to add more here, to actually calculate the local sidereal time. Okay, so your answer should be here, whatever that is. All right, so obviously if you look at this here, the first one is already done. Calculate J naught from the date given. So I've already done that to calculate J naught. So yeah, so first step is done. Second step is to calculate T naught. There's nothing like that in our spreadsheet right now. There's nothing like this on our spreadsheet also. Sidereal time Greenwich at 0 hour universal time. This one also is absent there, and the final formula here is not present there also. So I want you to actually complete this calculator so that you can give me the answer here. So what I'm going to do is this. I'm going to make this a group project. Hear me out, yeah. So we have a few assignment online, so, and I want to make this one group work, okay, which means that you have to actually, you know, work with your friends over the internet, online. Whatever you want to do is you got to work together, okay? I don't want you to work alone. In fact, I prohibit you from working alone. At least have a partner, okay? So this is a first project in the preliminary orbit determination from observation, okay, first one. So basically, what is it? Your project first time is to create a calculator for local sidereal time, okay, based on the algorithm already given and based on your understanding of Julian Day and local sidereal time. I want you to create a calculator, okay. I've done a simple ones here, okay, but this is just, I don't know, 1/6, 1/7 of the whole thing. Alright, so the big question is, given a local date, local time, and east longitude of the site, wherever that is on Earth, could be Moscow, could be, you know, Oslo, Nairobi, you know, could be, you know, wherever, you need to calculate the local sidereal time. Okay, example, say question is asking, find the local sidereal time of Kuala Lumpur, Malaysia on June 1st, 2007 at 7:30 Universal Time. Okay, so what's my expectation? Calculator. Okay, I expect your spreadsheet to be a flexible one, which means that if I want to change site, whatever on Earth, if I want to change site to Tokyo, okay, at 12 noon, March 1st, 2020, for example, I can do that with the spreadsheet. I can get the answer. If I want to change the site, the city to some other place, okay, I can do that always. And also user-friendly. User-friendly meaning that it's easy to navigate, okay. Usually if the spreadsheet size is too big, it's not too good. So like this, I think this is pretty, you know, user-friendly. I can choose the date here, choose the month, and then I can choose the city. It's easy, and I'll just pick a drop-down menu and then just give the answer straight away. Yeah, see. So I expect it to be also user-friendly. Maybe you can make it more user-friendly than what I've done there. Okay, so how are we going to conduct this? I want this to be a collaborative project, which means group work is a nicer term, because right now we don't have the chance to actually meet with each other to discuss, you know, just to, you know, do work in, you know, in university and so, like, we have to do everything online. Okay, so we will work totally online. And I know at first I wanted to do some programming work with this, but then I realized that one thing, not all of you have access to a laptop computer, because I think programming is better done on, you know, when you have actual, you know, keyboard to work on. So I'm thinking of just make it as simple as possible, so that's why I go for the spreadsheet route. So we will utilize this Google Suite app, you know, because it's familiar, it's the easiest option so far. Everyone have used it. We have used it extensively. We have even, you know, taken some tests with it. And also it's relatively smartphone friendly. That means you can work on Google Spreadsheet, Google Docs on your phone. It doesn't, you know, as opposed to, let's say, you know, you want to write a Python code on your phone. So that's probably, I don't know if that's possible, but I think I've seen someone do that, but I don't want to go that route. So let's do it with spreadsheet, easy. Okay, so mainly we will use the Google Sheets. what I've shown you just now, that one. And group member minimum 2, maximum 5. The reason I want to make it minimum 2 is because I don't want you to work alone. I really want you to actually train yourself to work with others, collaborate with others on your online. Okay, it can be pairing, it can be grouped. Like I said, that's why it's minimum 2, maximum 5. The reason I don't want to go more than 5 is because I know someone will just hitchhiking passengers, just ride along and not do anything. So I don't want for it to be more than 5. But I encourage you to actually join a big group so that you can learn from each other. You can just contribute a bit more here and there. Okay, so don't be scared yet. I think you just choose your own partner. I don't want to actually give you a list. Actually, I did want to do that at first, assign you to groups, but I think it's better if you choose to group yourself. Okay, just contact some of your friends, and let's say, hey, you know what, let's work on this together. Also, I think that will make you interact more with your classmates a bit. Okay, so why are we doing this? Because the learning outcome here is I want you to actually apply knowledge of orbit determination and create a tool for preliminary orbit determination. Although this is not the full thing yet, although this is simple, relatively simple, just calculating local sidereal time, but I want you to actually familiarize with the our way of working online first, do simple calculator, and then we can go on with the harder stuff. Okay, so just see this as our first step, learning the ropes, so call it. And I want you to also something that I want you to learn to involve in a complex engineering activity and a project online, because I think in your real work situation in the future you will have to work online. We have to get used to this. I know this is some of us seeing this as a hassle right now, working online and everything, but in the future I think this is going to be a new normal, a new norm. Okay, so let's take this chance to just practice a bit. You are allowed to make mistakes here. Let's see, who's that? Oh, no, my locals were all. Where was I? Oh, here. And utilize online tools, because I think before this you were not really used to actually check your email and use this Google Suite or Microsoft Office online, use all this online tool. So let's use this chance. You're learning after all in university. Let's just use this chance to just practice some things, just show off a little bit, what tools can you use. You can do this, you can do this online, because just want to let you know that actually not many people know how to work online. So let's take this chance. Yeah, so I've posted some the algorithm here and some examples also here if you want to check your numbers and everything. So let's start with you finding your groups, and then work on the assignment.